Hello everybody, today we will do a little bit challenging integral, okay? 0 to 1 log of x over 1 minus x all square here and then dx, okay? We'll name this as I, okay? In order to attack this integral, okay, we do the following substitutions, okay? We let x to the power of e minus v and then dx will be minus e minus v dv, okay? So after these substitutions, we will have this will become infinity, and this will be 0, okay? And then we put everything into the integrand. That will be e minus b here, and then 1 minus e minus b all square, and then dx is just minus e minus v dv, okay? Okay, we have a cleanup here, 0 to infinity, and then log can be cancelled by the e. Okay, so what we have is the minus v, and after square we only have v squared, and then we have here will be e minus v and then 1 over and then over 1 minus e to the power of minus v dv. Okay, now we want to change this part, okay, into an infinite series. Okay, we notice that, okay, for a geometric series, okay, simple geometric series, we know this is just x to the power of k when for the radius from convergence is 1, okay? And then we perform differentiations on this infinite series, okay? So what we have will become square here, and then k will start from 1 to infinity, and then k, and then times x to the power of k minus 1. And then we times x on both sides, okay? So we have x 1 minus x all squared will be equals to k start from 1 to infinity, and then k times x to the power of k with the radius of convergence 1. Now, we notice that this part, e minus v over 1 minus e minus v squared, just like this one, okay? When x is e to the power of minus v. So, we do the following substitutions, okay? We change this into this, okay, by using this formula here, and then dv, okay. Of course, we switch the integral sign and summation sign here, so this leads us to k here, and then 0 to infinity, and then v square e minus kv dv, okay. Now we have to calculate this integral here. Now we notice that, okay, if we let t to become kv, okay, then dt will just become k dv, okay, and then this integral will become 0 to infinity, and then v is just t over k all square, and then e minus t, and then dv is just dt over k, okay. So after some simplification, we will have k to the power of 3 here, and then 0 to infinity, and then t squared e minus t dt, okay. But we notice that this guy is just a gamma function, okay, with this is 3 minus 1, okay. So it's just gamma of 3, okay, and then over k to the power of 3. Gamma of 3 is just 2 factorial, okay. So 2 factorial is 2, so 2 over k to the power of 3. Now, we use this result into this one. So our integral 0 to 1 log of x over 1 minus x all square dx is just sum k start from 1 to infinity, and then k times what we have here is 2 over k to the power of 3, which is 2, and then some k to 1 from 1 to infinity, and then 1 over k squared. And this guy is very famous, we know this. This is just pi squared over 6. So altogether, what we have is pi squared over 3. So to summarize, what we have today is the log x over 1 minus x all square dx, okay, will be pi squared over 3. Okay. Hope you guys enjoyed this video. Okay, we will see you very soon. Okay, bye bye.